All right, let's continue our NoSQL injection series. So today we're really going to be focusing on, or in this module rather, we're going to be focusing on blind injection fundamentals. So let's check out the scope and kind of what you can expect. So there's going to be a bunch of exercises as usual. So the first one, we're really going to be learning about blind injection and leveraging it to find vulnerable server-side logic. And also, another exercise, use logical operators to dump all documents within a MongoDB collection. And another exercise, learning, and basically you're going to be learning how attackers, through hands-on experience, basically leverage client-side code to find vulnerable server-side routing functionality. So always put on the attacker hat, and that's how we learn how to defend our applications and just the internet in general. So doing a quick recap. Okay, what is NoSQL injection? Okay, introduced when developers create dynamic database queries that includes user-supplied input. So we've already gone over this, but here's kind of the important part of where we are within the series. So as I've said before, what unexpected input types could we receive? So binary, we've already gone over that. And last time we went over query objects, okay? But now we're going to be hyper focusing on a certain type of a certain query operator that can be leveraged within query objects called the where query operator. So that's where we're at. And of course, there's always other unexpected input types that we can always receive. So now I will slow down a little bit more and we could just go. But I just don't want to waste your time on things that we've already seen. But I just also want to give you context of where we're at. Okay, cool. Now that we've gotten that out of the way. Okay, so query operators. Let's start going into where. Now, where? Okay, so matches documents that satisfy a given a JavaScript expression. So here is an example. So we're querying basically the accounts collection, and there's that where query operator, and this dot password equals unfortunately something from the request. Now, I've seen this in the wild where unfortunately a developer or somebody else, well, a developer is doing the code, so a developer will can kind of concatenate in this untrusted input. So anyhow, but where operators. A where query operator, excuse me, doesn't always have to leverage, this, but just this is just kind of giving you an example of kind of unpolished code. Now, here's the thing. So this JavaScript expression, okay, in here, all right here, now is invoked for each document in the accounts collection. And here's the thing. So the current document is referenced by this. So this is whatever the current document is as it iterates through all of the documents within the accounts collection. Now, here's the thing. Now, where whitelists certain JavaScript functions, okay? So that could be potentially injected into request input right here. Now, what are some of these whitelisted functions? So you can kind of pause the video if you'd like and kind of look at these, but basically we're going to be kind of leveraging these in a thought exercise right here. So here's the thing. So after the attacker injects request input, okay, let's just assume that they have no way to view the response. So they inject this, but they can't really see any text that comes from the response. Maybe the server is just, is obfuscating all of that, right? So it might just give you the attacker a 400 not found or 404 not found. Okay, so but here's the thing. Now, whoops, sorry, this is kind of going off the screen. This was unexpected, but basically the item here is, let's just say an attacker injects request input. What function up here could have the largest negative impact? Okay, and just remember the assumption that they have no way to view the response. Okay, so printing something, for example, wouldn't really do much in that situation. So I'm just going to kind of continue within a couple of seconds. You can pause the video if you want to think about it. Okay, so the answer. Now, in my opinion, it's really that sleep function. Okay, and what does this do? It suspends an execution context for a specified number of milliseconds. And okay, so what is the intended usage here? Like, why would Mongo want to allow this? Well, okay, one example is, I'm sure there are others, but is basically slowing down bulk insertions to minimize some resource footprint. So for example, say somebody wants to insert all these documents into a production database. They don't want to overload it, say, and with, real customers leveraging it, right? And we don't want to impact, customers, and kind of their performance, as they leverage the site. So anyhow, that's kind of the idea is you can slow down some of these. But what's some unintended usage of that sleep function if an attacker can inject it? So just kind of think about it. There are actually, I have come up with two of them. So if you think of one, just kind of pause the video for a second, see if you can come up with maybe two unintended usages of the sleep function. So now I'm going to continue and show one of them. So what's if an attacker, basically this is a denial of service risk. So what's if the attacker invoked hundreds of let me rephrase this. What's if an attacker invokes hundreds of requests with sleep within it, okay? And say like a route or something like that, okay? So what happens then? Well, that would be really bad because basically sorry, I was about to show the other answer. But anyhow, if that happened, all of these execution contexts or processes would be left open for the millisecond duration that the attacker puts in. Okay, so that could really hang the server. So now I'm going to go ahead and give kind of the second unintended usage. So check this out. Mass injecting sleep to observe response times, okay? And this is really kind of an example of blind injection where the attacker cannot directly view the text in the response body, okay? So they are blindly injecting, but they are leveraging other information to kind of deduce if the injection was successful or not. So within the sleep kind of example, if they're injecting sleep into, say, some kind of parameter or something else that accepts it and runs it, well, if the response comes back whatever milliseconds it is later, they can make it to 2 seconds, 3 seconds, or whatnot. They know that that one parameter is vulnerable, and then they also know that where is being leveraged, that where query operator is being leveraged behind the scenes. They also know that through this as well, okay, if this works. So that's when they pretty much can inject this all over the place, this sleep function, and see wherever that response kind of takes a little bit more time. And then after that, they can start digging deeper. And that's kind of basically what we're going to start doing here. So let's go ahead and do a real, exercise here. So crafting the payload, and we're going to do a little setup first. So go ahead and do your Docker run command in the terminal, okay? Then this exercise is really an extension of kind of a previous exercise that we have done within the NoSQL injection, query object injection kind of tutorial. So if you have not done that, please go back and I would highly recommend checking it out, or you can click here and at least kind of go over the show notes, and that might kind of help you out if you feel stuck kind of on what we're doing. Okay. So then, after you do that Docker run command, go into localhost 3000 in the browser and find dist juice shop min.js. And I'm gonna show this real quick for you for those of you who have not kind of gone through the previous tutorial. And then after that, you're going to be searching for factory product review service. So let's go ahead. Let me just make sure. Okay, yeah. Let's go ahead and do that now. So I'm over on localhost. I am control clicking. This is on a Mac, and then I am going to do inspect. Then after that, I'm going to go up here into sources, and I'm going to go into dist. juice.min.js. Then I'm going to go down here and pretty print it. So a little tongue twister. Okay, and then I'm going to do a command F or find, and then I'm going to copy that in. So here, right here, this block of code is really when you see the assignment, this is kind of the confines of what you need, okay? And also know that everything within the assignment that I give can be deduced from information within this code block, okay? And you know what? I know for some of you, this might be like, oh, this is kind of like annoying going through the client-side code. But to me, this is really foundational, just to learning, okay, and also seeing it through the attacker's eyes, which really helps us defend applications. And yeah, yeah, I think this is just absolutely pivotal. Okay, so so you have that. Now, here's the thing. Given the routes defined in that product review service or that highlighted block that I just showed you, execute a request that makes the server sleep. Okay? Now, kind of give that a shot. And I have a couple hints, but give that a shot. And it might be really helpful once again to go back to the previous tutorial and look up the curl template that I had in there. But also, if you haven't done that, just try giving it a shot anyways. Okay. Now I'm going to go ahead and start giving a couple hints. Okay. So here's hint one. There is this kind of piece in there, okay, within that product review service. Now, think about how you can leverage this to kind of deduce where you should be injecting sleep, the sleep command. Okay. And here's hint. I'm just going to extend this hint a little bit right now. Now, and here's really the crux of this, of just this, kind of crafting the payload and this just assignment. What does E tell us about the server-side logic? And that is really how attackers are going through the client-side code, and they're leveraging that to really understand code that they cannot see behind the scenes. And here, we'll go ahead and answer it. You can pause right now if you so choose. But I'm going to go ahead and answer that right now. So the server is basically accepting dynamic input, right, or untrusted input from the user, okay? We don't know if they're leveraging it in an unsafe way, but it is accepting input from the user, okay? So this is really what would be a prime target for attackers to start injecting, okay? Now, kind of given that, try to make the server sleep. Okay, and I believe R is, yeah, that's all defined in there as well within that code block. Okay, so I think now is time for the answer. Okay, so crafting the payload, here's the answer. Okay, as we saw, this ultimately it was E. Okay, and you can go ahead and inject that sleep command. Now, of course, the attacker could automate this, but here's really the interesting thing. Some of the best, from what I have seen, attackers out there or individuals who are white hat hackers, okay, really hyper focus on manual testing of going through the code and figuring all this stuff out. And the reason why is because a lot of, say, defense kind of software is automated in a certain fashion, and a similar in a similar way, a lot of reconnaissance kind of software is automated in a certain fashion, right? So if they are leveraging kind of tools that automate all of this injection, basically it would be pretty basically it would be they would probably get very similar kind of results. Okay, so here's the thing. So they are probably going in and looking at this stuff. So I would really suggest that you look at it as well. So here's the thing. So if the response was lagged by 2 seconds, okay, the attacker knows that the route is vulnerable to where injection. Okay, now let's start diving even more, kind of going into diving deeper into where, just because we know now that there is the attacker, if we're putting on our attacker hat, the attacker now knows that this parameter is vulnerable to kind of where injection. So what they would do is they would start diving deeper. So in a similar fashion, let's start diving deeper here as well. So in this example, and or actually exercise, you're going to be looking for unguessable quote unquote identifiers. And what do I mean by that? Now, and I'll go into that in a second. But basically here, there's going to be what you're about to see is some ideas or just facts that are going to help you with this assignment. So in certain banking applications, okay, I've seen this where you have example.bank.com, whatever your bank is, and you see statements, and then you see some random number. And really, it's just like this long, crazy kind of like GUID or whatnot. And so when people see that, sometimes they wonder like, well, what is that doing? And that in a lot of contexts, the reason why that's there is because this whole URL is public, okay? But that random number is appended onto the end or wherever it is, basically as a proxy for authentication, okay? So only you would probably, or hopefully only you, know that random number, or were given a link with that random number in it. And then, so that's kind of tying you to that, basically to whatever, to say in this example, whatever the statement was, your banking statement. Sometimes you will see this with like password reset functionality that is sent to your email. You'll see some like crazy long random kind of integers, or you hope that they are random, and that's kind of why. But here's the thing. Now, starting to kind of think about from a NoSQL injection standpoint, how can all these random numbers be divulged? And kind of start thinking about that within kind of the context of where injection. So here, so let's kind of continue to ideas or facts, okay, that will help you with the assignment. So the second bullet here is that where is essentially finding a condition that is true. So as we saw, iterating through the accounts collection, it is trying to find, so this dot password is equal to some piece of the request, and if this evaluates to true, then that the resulting document is then returned. Okay, so essentially that's what where is doing, is finding a condition that is true. Now, here's the other item, okay? Extending off of that condition in true is that where accepts JavaScript syntax and in particular JavaScript logic operators, okay? So that's kind of the thing right there. So think about that for a second, and now we're gonna really kind of dive into the assignment. So, okay, so we have our URL right here. And then, okay, so here's the thing. So inject me to retrieve all product reviews. Okay, so do that, all right, given all of these three bullet points. See if you can kind of leverage those to get all product reviews. So if you put in one right here, okay, you will just get one product review back. But how could you change that inject me to get all of them back? Okay, so think about that for a second. Okay, so you can pause the video right now, and I'm just going to go ahead and kind of continue. I believe I have some hints coming up, which I do. Okay, all right, so hint number one: leverage JavaScript logical operators to force an always true condition. Okay, so kind of go back and check that out. Try it. All right, so after that hint, I'm going to continue. All right, so here's the answer. Now check this out. Here is the injected piece. It is one or true, which will always result to true. So check this out. If we go in here, we copy this, we go through, and boom, all of the basically all the documents came back. Now, as just a comparison, we can delete and just do one, and then boom, only one comes back. So that always, since that always evaluates to true, everything is returned. Now, what are some takeaways here? Now, attackers already know a lot about your private server-side code through your public client-side code, okay? So that's kind of the thing, and that is even more of a motivation just to go through and really lock down your server-side code because it's very easy to deduce that information through publicly accessible means. And the other item here is really a key takeaway is when possible, never whitelist any characters that can be leveraged to create a logical operator, okay? So for example, this pipe or the and, for or an and, okay, that could be ultimately made or and, okay, etc. So yeah, those are definitely the takeaways. And yeah, thanks for listening. Hope you enjoyed it.